Hi, today I'd like to start by trying to write these expressions in the form x plus a all squared plus b. That is to say, can you complete the square on these? This lesson assumes that you've done one or more completing the square lessons. I'm not going to go through these in detail, but here are the answers. Essentially, we're having the number in front of the x. That helps us complete the square. If you remember the Babylonian method, then we need to minus the square of that, in this case 16, so minus 16, and then simplify, so we get a minus 15. Similar for the next two, and we end up with fractions on this one. You might have left it as mixed numbers. This one would be 8 and a quarter, and this one would be 21 and a quarter, I think. Today we're going to look at using completing the square to solve equations. And I'm going to go through some examples, and then hopefully you're going to try them as well. So the ones on the left are for me, and I would like you to try the ones on the right. But let me go through one, and then you can join in. Of course, if you're really confident, you can have a go at it. There's no problem with that. So to solve x squared equals 25, in the past, actually, let me say the way that you want to do it. You simply want to take the square root. You can write the square root if you want, but basically you're going to take the square root of 25. But don't forget that, sorry, it's my pen. Don't forget that when you take a square root, you need to include the negative square root as well. There are two answers to this. Now in the past, you might have solved this by minusing 25 from both sides and then factorising it. So it's actually a difference of two squares. You'd still get plus and minus 5. Be aware of both methods actually. In this case, this is the quickest one, and we're going to be using this kind of method today. So try the next one here on the right. You should get x equals plus or minus square root of 36, which is plus or minus 6. All right, how about this one? Well, in the past, you might have squared this to get rid of the bracket, minus 4, and then tried to factorize it, but we can actually use a similar method to what we've just done. We can actually square root both sides. It's okay to do this because the square is around the whole thing. If you had sort of x squared minus 3 squared and you square rooted it, that is not nice. But because the whole thing is squared, we're okay. So we get x minus 3 equals, and then we take the square root of 4, which is 2, and we get plus or minus. I've just avoided writing the square root now, but you could add that if you want to. And then I'm going to get two situations. I'm going to get x minus 3 equals 2. Because I'm not finished this time, I can leave it like that, I suppose. I could maybe say 5 or minus 5, and 6 or minus 6, just to make it even clearer. Here I really should be doing this. X minus 3 equals 2, or x minus 3 equals minus 2. And that's going to give me x equals 5 or 1. So a slightly different take on this, but I can do the same kind of thing. Okay, try this one. So if we square root, we're going to get x plus 2 equals plus or minus the square root of 9, which is 3. That's going to give me x equals 1 or minus 5. I've done that more quickly, but 3 minus 2 is 1, and minus 3 minus 2 is minus 5. Right, we're just slowly making it more difficult. This one here, well actually, what you want to do is not expand it or anything, but change it so that you've got this thing squared equal to 100. We don't want to take the square root yet, because as soon as you get a minus in your square root, it's not very as easy. But let me just sort this out. But when I can write it in the form like we've just done, it's absolutely fine. I can write x plus 5 by taking the square roots equals plus or minus square root of 100, which is 10. And that's going to give me this time x equals 5, 10 minus 5, or minus 15 by doing minus 10 minus 5. So similar here, give it a go. Well, we're going to get x minus 1 squared equals 16. We are going to square root, so x minus 1 is equal to the square root of 16. That's plus or minus 4. X equals 5 or minus 3. And here we go. I didn't want to just start with this, but this is the sort of thing we need to be able to deal with. Solve this equation by completing the square. So there's some extra steps now, because first of all, we've got to do what we did at the start of the lesson. X minus 1 squared minus 1 minus 8 equals 0. I've completed the square. That's going to give me x minus 1 squared minus 9 equals 0. I can just go straight to equals 9. Now I'm back to where I was before. X minus 1 is plus or minus 3. X is equal to 2, or, wait, not 2, that's not right. X is equal to 4. If I add 1 to 3, or minus 2. Try this one. X minus 2 squared minus 4 minus 12 equals 0. X minus 2 squared equals 16. X minus 2 equals a plus or minus the square root of 16, which is 4. X equals 6. I take the plus 4, and minus 2, I take the minus 4. One more. You might be asked not to complete the square, but write it like this. X minus the same thing. X minus 2 squared. I'm still minusing 4. Minus 7 equals 0. X minus 2 squared equals 11. This time, we're actually going to get the square root of a number that's not a square number. So it's going to be plus or minus root 11. And our final answer is just going to be 2 plus root 11, or 2 minus root 11. So I've thrown this one in at the end. We're going to mainly focus on whole numbers to start with, but actually we're already getting onto later bits of the lesson where all of these ones before would have factorized, because we get nice whole numbers as the solutions. They would have gone into brackets if you could put this into brackets. This one here wouldn't have factorized. So you've got two methods for solving this one. Quadratic formula, if you remember that and learn how to use it, but we can also complete the square, and actually completing the square is probably quicker. So all of them have got different advantages in different situations. Hopefully you're feeling all right about this. So I've got a load more questions for you here. Now if you're feeling quite comfortable, then maybe do every other one. Skip through question 1, because actually you've already done a lot of those. And try 2 and 3. 3 is a little bit trickier, because when you complete the square, you'll get decimals going on in the answers. Anyway, you decide what you want to do. Pause the video, try these out. I'm going to put the answers up now. So, load of nice answers for number 1. Number 2 is an interesting one. You'll actually get a minus on the right-hand side, and then when you square root a negative, we run into difficulties. There's actually no solutions to this equation. Previously, if you've been using the quadratic formula, and sometimes people type things in incorrectly, you get math error. That basically means there's no solutions there. If you use the quadratic formula, you would get that here. Number 3, here are the answers. You do get a nice whole number answer still, even though you've got decimals, it all works out. So that was more of an extension, but I hope you're okay with that. Now have a look at this. Simone solves this equation correctly using the method below on the left. Could she have used a shorter method? What do you think? So factorizing works if we expand it out and then factorize it, brilliant. But we've now got this other method. We can just complete the square. We can make it x plus 4 squared equals 1. So x plus 4 equals plus or minus 1 when you take the square root. And we're going to get minus 5 or minus 3 from that. So less steps actually. It's it might seem first that it's a more complicated method, but once you've got your head around it, it is better. Of course, if you started with this equation, yeah, it's going to be quicker to factorize. It all depends what you start with. To summarize so far then, completing a square can be a good way of solving quadratics. We've got these two methods, factorizing and quadratic formula, and there's different situations when which one will be advantageous. Just make sure you are confident with both. Today we're looking at completing the square. Of course, it gives a turning point as well, so that's another useful application allowing us to sketch graphs. But now we can also solve them and find roots when y is equal to 0. And I think, yeah, we're getting on to the last little bit. So the ones before, we could have just factorized, it would have worked. But now we're going to see some that that won't factorize, and actually, arguably, it's going to be quicker to complete the square than use the quadratic formula. Remember, we don't even know at the moment where the quadratic formulas come from. It's just this like random formula that's come from nowhere that we've accepted. We're going to look another time at where that actually comes from. But right now, we need to focus on this because actually this is going to help. So again, I'm gonna do an example, and then you have a go if you like, or you can pause the video and try them yourselves. So if I want to solve x squared equals 27, I can just take the square root of 27, plus and minus. Now it's asked me to leave it as a simplified surd, so this brings back the topic of surds. We can actually find the largest square number that goes into 27, which is 9, and we can rewrite it as 9 times 3 and then separate the surds. I've just done that quickly. So I'm going to get plus or minus 3 root 3. That is the simplified surd. Try similar for this one. Here we're going to get plus or minus the square root of 32. Now the largest square number that to go into this is 16 actually. So it's going to be plus or minus the square root of 16 root and then root 2. And that's going to give me 4 root 2. It might be that you took 4 out and got 2 root 8 as your answer, but you can simplify the root 8 further to 2 root 2, so the fully simplified answer is 4 root 2. That was just really getting us going for the main event now. Can we solve this by completing the square? Yes, we can. X plus 3 all squared minus 9 plus 7 equals 0. X plus 3 squared, that would give me minus 2, so it's going to equal 2. Now I'm going to take the square root. X plus 3 equals the square root of 2, but plus and minus. And I'm basically done. X equals minus 3 plus or minus root 2. Our answer is a surd. We could write, maybe I should write it just separately because I've been doing that previously, minus 3 minus root 2 or minus 3 plus root 2. So, like I said, we can't factorize that. We could use the quadratic formula, we'd get the same thing. Often you'd ask to leave it to significant figures in that case, but we can leave it exact. Try this one yourselves. Very similar, x minus, just doing this is just more practice of completing the square. So it's all good. There we go. X minus 1 all squared minus 1 minus 5 equals 0. So x minus 1 squared equals 6. So x minus 1 is equal to the square root of 6, but plus and minus. X equals 1 plus root 6, or 1 minus root 6. Nice one. Hopefully you're feeling happy about this too. A few more questions to try. Go for it. So this time all your answers are going to be in simplified surd form. Some of them get a little bit tricky at the end. Try and do all of this without a calculator like I've done throughout. All right, how'd you get on? Here are the answers coming up. There we go. So lots of roots. In some cases, we get root 24, for example, which you can simplify. So that's what I was hoping for you to do. Sometimes you get prime numbers or just numbers that don't get a square number doesn't go into them except 1. This very last one, you get root 325, I think, which you can actually write as 5 root 13. So hopefully you're completing the squares in a good place. You can now solve equations by completing the square. Well done on your effort.